Hello and welcome to Security Beside Athens. My name is Romansh Yadav. I will be the instructor for this workshop. This is our content. We will cover Android introduction and basic. We will set up Android pen testing environment lab, and we will do some reverse engineering practical and some basic practical as well. We will do. And the last we will see application component and security issues. And we will also do some Android static pen testing by using the tools like MovSF. So this is the Android architecture. We have 5 layers in Android architecture: application framework, library, Android runtime, and Linux kernel. Each layer is responsible for doing the different operation. At the end, these all layers support a application for doing their work for operation, like a mobile banking application or browser based application like Chrome. So every application which we install inside the mobile device got different support from a different application layer, like suppose library. So we have web browser like Chrome, Mozilla install in our app mobile device. So we have library like WebKit. So WebKit library support the Chrome browser. So we have like power management in Linux kernel. So basically Linux kernel is very important. It is like the heart of the Android architecture, and it's provide process isolation, power management, flash driver memory, camera driver, display driver, USB driver. So Linux kernel is very important, and then it's come with there is a application framework. So we get activity manager, window manager, content provider inside the application framework, and they at last where we install our application like contact, home, phone, browser, banking application, chatting application, etc. So this is Android application fundamental. So basically we know all the Android's apps written in Java programming language, and Android SDK is responsible for compiling your code. Suppose we write a code in any IDE like Android Studio in Java programming language, right? And so basically IDE comes with the Android SDK. So it is the Android software development kit that compile your code into the APK, and then APK we install into our mobile device. So we will have a quick look at the Android Studio. So this is Android Studio, and we will close it, and I will start a new project. I will start a new project. So this is the templates. We can select any template like bottom navigation. We will select it. It will come with the activities. I will. You can name it anything, right? So our project is loading. So this is our Android Studio. We this it's these are the file structure of our application. We can see there are different files like library, source code. All the source code is here. Main. This is the XML file. This is the central file of any application in Android, and we can say here main Java, and this is the main activity. So basically what is main activity? Main activity is something whenever we open any application, the first activity will be the main activity. So we can open it here. So this is main activity. We can add any .java file, we can add any activities, right? So I will try to run it. It will build up automatically, and yes, it will build automatically, and then it will start the emulator, and it will install automatically inside the emulator. This is how it looks like. It's already installed actually. Okay, let me go this one. This is okay. Both are same. We can say this is dashboard fragment. Sorry, this is notification fragment. This is our emulator here. So basically, Android Studio is something. It is an IDE, integrated development environment, where we develop our Android apps. We can go, we can write our own activities, we can modify any activities code, right? So whatever, like you want to develop a chatting app, you want to develop a banking app, whatever you want to develop, you can use Android Studio, and it will automatically come with the Android SDK. All right. So this is the Android file system structure. I'm talking here. I am talking about the Android operating system file structure. This is and this file system. This is file system is this is for the apps, Android apps, but this file system structure is for the operating system. So it is pretty much similar to Linux. There is a single root here, and we have SD card folder and external SD card folder. So if you put any external SD card, it will appear in Android file system structure. And this is the main important things that Android do, because Android manage sandboxing and permission model is a very unique way. So whenever we install a app, suppose we install two app 1 and app 2. So when we open or when we start our app 1 will get a unique process ID, and app 2 will get a unique process ID. So basically app 1 will get a unique user like a UID, and app 2 will be treated as a unique user from the Linux kernel. So Linux kernel give a unique ID to app 1. It will treat app 1 as a user, and it will treat app 2 as a user. So app 1 cannot use the resource of app 2, and app 2 cannot use the resource of app 1. And inside the data folder, app 1 can store their whatever data they want to store, and app 2 can store their own data inside their own folder. So they cannot access the files and the data of each others without the permission or without the use of intent, right? So this is how Android manage permission model and sandboxing. And this is the process of creating APK. Basically, as I show you in Android Studio, we write Java programming, and we develop Android app, and then we compile the code by using the Java compiler, and we get the bytecode, and then again we compile bytecode with the help of Dex compiler and with resources, all the resources and data, and then we got the APK file. So this is the diagram for creating a APK from the .java files. This is a Android component architecture, a diagram. So we have different component in Android, like activity. So activity is a screen, like single screen, we can call it as activity. So this is home fragment, this is a activity. Now this is dashboard fragment, this is notification segment. So notification, dashboard, these are the button, but this is the this is notification segment is the activity. So activity is a screen, and these are the buttons. And services like suppose we are doing some chatting and in the background we are listening some music, so that music will be a services. Broadcast receiver is like when our phone battery is going to down and we receive a alerts that your battery is going to be down 5% below, 2% below. This is a broadcast message. Or when we apply DND, so at the time of 10 p.m. it will automatically appear that do not disturb mode is enabled automatically. So it is a broadcast message basically. Content provider basically content provider component supply data from one application to other on the request. So when the request from data from one application to other, so it will be done by the using the content provider. And we have additional component like intent. So intent is also very important. So intent is like when intent is like a messenger. Suppose we need a data from app 2. Suppose app 1 needed data from app 2. So with the help of intent we'll send a request to app 2, and app 2 will transfer the data with the help of content provider to app 1. This is something how they work together. Now let's create the pen testing environment lab. So for creating the pen testing environment lab we need a emulator. So we can use this emulator, Android Studio emulator, or we can use the Genymotion emulator. So I will use Genymotion. I will show you how to install the image of any Android operating system. So I am going to open my Genymotion. So Genymotion you can download from here. This is the website. Genymotion you can download and you can install it for Linux, Mac and Windows. So basically Genymotion work with VirtualBox. So you need to install the VirtualBox in order to run the Genymotion. I already have the VirtualBox. So these are the images. So when you install the Genymotion, you open it up and you log in inside the Genymotion, and you will find there are so many images. These are the custom devices, so you can install any image. Make sure it should be like API 23, Android 7, 8. It should be something not too much latest or not outdated. So we will do. So here if I want to show you how to install it, just click on this button. So I will show you on some latest one, 8. Right, custom phone 8, this one. This is you install it here, NAT, default is NAT, custom phone 2, and it's start downloading. It will when it will complete it automatically. So we can create it. So when it will complete it, so in the meantime I will start this one. It already installed. So it is starting virtual devices, and you can see here custom phone 1, it's running in the VirtualBox, right? This is the here image. It is booting up, and this is our IP address, you can see here, and we also get the message to that device installed, device has been installed. We can start this as well if we want, right? Because just I want to show you how to install it, that's why I install it. And now okay, now it's already started, right? So now first we need a app. we are going to do a pen testing, right? So we need a app where we can do our pen testing practice, right? So we will do our pen testing practice on a very good app, Piva. Piva can be find here. It is a very good app and it is developed by ST. So why I am choosing it, because it's covers so many vulnerabilities. You can see here vulnerability cover. These are the vulnerabilities that it's cover, and it's help us to explore more vulnerabilities so that we can learn about the more vulnerabilities. The more name we know about the vulnerabilities, the more we'll learn, right? So we will use this app. You can download it here, APK, and this is the APK. I already have it. Click on download. I have 5 files actually. So I downloaded it, and now I will try to install it inside this emulator. Before we going ahead, we need one more tool called ADB. And what is ADB? Basically, you can learn about the ADB here. ADB is a bridge that will help us to communicate with the device or with the emulator. So with the help of ADB, we can easily communicate with the emulator, right? So you can learn about it, what is the ADB, how we connect, and what are the command that ADB provided to us. ADB is actually very good tool, or it will automatically come with platform tool. If you download the Android platform tool, if you download the platform tools, it will come automatically with ADB, fastfood, Systrack. So these here, they are platform tool already. Windows, Mac, Linux. You can download it. I already downloaded and installed the ADB in my system. So now I will try to run ADB, and you can see there are so many commands. Now we will go up and we will start seeing the different commands, right? So first is like devices. So devices command will list all the devices, right? ADB devices. So now you can see we have two emulator, this one and this one. So this emulator belongs to Android Studio. You know, we already this emulator, this one, right? And both are connected, right? Now I will try to install the Piva application in both emulator, right? So now I will go into my directory, so now I am going to copy that Piva file inside this directory. Downloads Piva. Which one I should copy? 5 1. We can copy anyone. let's try to copy this one. Okay. CP. Okay, now we get the Aptiva file. ADB devices. Right. Now I am going to install this file. Let me change the name of this file. Now it looks fine. Right. Now I am going to install it in, we can install it in any emulator. Okay, let me, we don't need to install the file in this emulator, Android one. I will, so you can see that emulator is gone, disappear. ADB here. So this is the command that will install the Aptiva application inside this Genymotion emulator. Now we can see install has been successful. Okay, let's go to the device and check. Here we can see, and we can open this application. This is the main screen, main activity of this Aptiva application. So why I use Aptiva for the demonstration purpose? Because it contains so many vulnerability. Now you can see here, there are so many vulnerability, login, encryption. So it will give you an idea actually that what kind of vulnerability you can find inside a application. Of you are a beginner, then you don't need to go into the reverse engineering, you don't need to go to start Frida as a beginner. So as a beginner, it will help you to understand the what kind of vulnerability can be found inside the mobile app assessment, right? Dynamic code of loads. Here you can see services, ADB shell, AM start. AM is activity manager, so ADB shell give a command to activity manager to start the particular services, like this they have written here, right? So these are the vulnerabilities that we can easily learn, and we can easily try to find out inside any assessment. And if we see the about the project, we see, as we see this in Aptiva website, so these are the detail of the vulnerability that cover in this application. We will not cover all the vulnerability, we will cover a very few vulnerability, but it will helpful for your learning purpose. So this is why I always choose this application for demonstration. So almost we are all set with our pen testing lab. One thing I also want to highlight, there is a VM, mobile Excel. So this VM is very good. It is very good for both Android and iOS. So basically, if you do not want to set up or install the ADB or Android platform tool, Genymotion, and all these stuff, you do not want to install it. So you can, what you can do, you can download this mobile Excel VM, and then you can start your pen testing process. You can create your lab and you can start all your pen testing. So, but in that also you need to install Genymotion in a different environment, because it is not come with Genymotion. It come with the Android Studio. So you can use that emulator if you want to use the Android Studio emulator. You can that. use that. So this is the mobile Excel. You can find it on its website. You can find it here on GitHub as well. Image. Oh, you can. This is the website. It will give you all the detail about the mobile Excel, and it's very good actually. It's very good. Download. This is download form. This is download page, and this is the home page of the website. Android zone, iOS zone. So I will show you. This is when you log in, download and install in VirtualBox, and you log in. So you will get these stuff: SAC zone, iOS zone, Android zone. So you will get almost all these files like JD, GUI. It's very good too. Sometimes it's create problem while working on Mac. So you can work on this. Fashion Fluid is very good framework for iOS, and you can start MoveFS is very good tool for static pen testing. It will give you the overview about the application, how many activities are there, how many content provider, how many broadcast receiver are there. So more SF, we will see it. More FS browser, you can find this a very good framework browser, and you will get a lot of tool in this VM. You will get verb suite as well. So many. It's good to use it. Recently use, suppose I want to use more SF 12345 is password, so it will start mob SF, and I can, it will start the mob SF. It's a very good tool. I will show you. I just started for the demonstration. I will not do any assessment right now. I will do later end of the workshop. It is starting. Let's just start. Right. So now, what we almost set up the our environment, pen testing environment, and we almost install the application. Right. Now we have the APK. Suppose we are working in any company and industry, we receive the APK, and our setup is already ready. So what will be next step? So next step will be the approach. This is done. This is the next step. So we know there are two testing approach. One is static pen testing and other is dynamic. So what is static pen testing is? Static pen testing is when we do pen testing when code is not running. Code, we have only code, we have only APK, and we are not going to install it, and we are not running the APK inside the mobile device, and we are doing the pen testing, or we are doing the source code analysis on just the APK file. That's come inside the static pen testing. And dynamic is something when we install the application, we run, we start intercepting the traffic into a verb suite, we start hooking the application by using feeder tool. So and we try to bypass some restriction like SSL pinning or like root detection. So all these activity come into the dynamic pen testing, right? So now let's start with static pen testing. Let's start with static pen testing. So first of all, I will start with this tool, mob SF. It already started here. You can click on it. It will appear. You can see it's already there. Fashion, yeah, fashion fruit I have. So when we open the WoW SF, it's a very good tool for basically static. Dynamic, we can do dynamic as well, but dynamic will not give you the proper very quality result. So what we need to do, just we need to just drag and drop the application. So this is the Aptiva. I will upload it, and we will get the result in a very few minutes. Right? When we get the result, it is not perfect. So what we will get the idea. We will get the idea how many. Uh, we will get a overview. Right? We will get a overview of the application. So let's see. It is analyzing the application, and it will give us an idea about the application, because the more we will dig the application, the more we will try to find out the loopholes. It is kind of recon. So for the recon purpose, you can use this tool, and now we get a very good screen, a very formatted output. We can see, right, it gives their output as well, that what can be the vulnerability, but till the end you can see this application. Till the end you can also download a report from this MovFS, but see, if you click on report, it will come like this. It will also mention the vulnerability. Either these are not vulnerability, but it's fine. I mean, for the purpose of understanding. So we will go one by one. So now we almost get the result of the mov sf. Now see, so this is the application name, and this is the package name, com.establish.viva. This is the package name, this is the main activity name. We can see here SDK target SDK 26. We can see here Android version is 1.0. Right, security score we can see here 10 out of 100, because it's a vulnerable application, of course. Now, as I told you that we will receive a overview result. So we can see here there are 10 activity in this application. So we get to know now that there are 10 activities. So we can go to the activity, and we can see, okay, these are the activity here: main activity, encrypted activity, web view activity, database, cloud load activity. So these are the activity we can try to get into further, right? But for right now we know, okay, there are 10 activities. Now again we will go to, now we see there is one services, okay, and that service is exported. That means it can be used by other app if it is exported. So we will go to services. So this is the services: handlers, vulnerable service. This is the services. This is receiver, this is content provider. We can see here, this is the content provider, right? Content provider, receiver, broadcast receiver. Now here we can see, if we need to set up a dynamic if we want to start dynamic analysis, we have to set up the dynamic. So in that case we need a emulator for this particular move SF. Now we can download Java code, we can download Smiley code, we can download APK. APKs we'll already have. So now we can view Android manifest file here. We can click on that, and we can. So what is Android manifest file? Android manifest file is a central file that contain each and every information about the app. Suppose what permission need when we install the application inside our mobile device, that all are written in Android manifest file. Suppose NFC, write, external write permission, read external read permission. So these are the permission that required in this application when we install it. So you can check it. If suppose it is not a banking application, there is no need for NFC permission, right? Nearby protocol. If near frequency protocol, if there is this, if it is required or not, read profile, read context. So based on the property of application, we can decide how much permission it is required. And now we can see activity. This is the intent filter here, right? As we know that there is a main activity that is exported, right? So if a activity is exported, that means they have defined the intent filter also. And these are the more activities here. Exported is true as well, so you will find intent. Yeah, right. So okay, this is done. This is, that's it. This is the small Android manifest file. But it is very important to go and learn about the Android manifest file, as it will give us the too much knowledge about the application. Right. Now let's try to decompile the application by using other tool. Right. There is a tool called D2J Dex2Jar, and this is a Java decompiler. D2J Dex2Jar. It will decompile the application into a jar format. The file is already there. So let me remove the first one. Now it is decompiling and we are getting the jar file. And okay, I will open it into the Java decompiler. JDGUI. This is the Java decompiler. And now I can see the source code of the application. Now here you can see, you can open about activity, you can open broadcast activity.class file, build config.class file. It is debug or not? Yes, it is debug. Configuration file, you can see, you can my vulnerable, you can very complicated password, you can see the password here. Sorry, web view link, you can see here. So username is test, you can see here. So you will find out the hard coded sensitive data if something is hard coded inside the mobile device, and you will surprise that still we find this vulnerability in the modern application. Still we found sometimes the key, the token, the API keys, or sometimes the username itself inside the hard coded inside the application. So this is how you can decompile the application by using the J2 Dex2Jar and JDGUI. Right, and suppose we are not able to identify anything, we go to search, we start searching. We'll click on, we want to search in everywhere, Java module, method, constructor, everywhere. Username, so it will come like this. Okay, and we see username got highlighted, right? And we got the username test. Suppose you want to search password, you can search here password. It will highlight all these password. Here password, so you will find the password. If you want to search the token, we can see here it will highlight token is not a valid media session token object, right? if you want to search the key, so it will be appear here. So this is how you can search. Search is very good actually. Here. So this is how you search API, and so on and so on, so many things, right? So we can find easily if something is hard coded, if some sensitive information is hard coded, we can easily find. If we want to find some username, administrator, right, local test we can find, guess we can find. So that's it about it. So still what we are doing is still a static pen testing. We did not start our application and start doing the dynamic pen testing. This is the static pen testing, right? Now I want to go into further. And now let's do reverse engineering. Let's try to reverse engineering the application and then try to see what we can do, or we can tamper the application or not. We can sign the application again with by using jar signer or not, right? So basically there are two things, one is tampering and one is reverse engineering. Tampering is a process where we do reverse engineering the code. So what we have a APK file, we try to decompile it and get the source code, and then we try to modify it we try to modify it, we try to inject our code. We basically, it's called tampered. We tampered the APK and then we rebuild, resign, and then we install that tampered application. But in this simple reverse engineering, we decompile and recompile and resign it. So if we want to recompile and we want to tamper also, so we have to inject our code in somewhere so that we can easily recompile, resign, and that application can be useful for the malicious purpose, or it can affect any victim, right? So there are many tools for decompilation, as I show you Java decompiler, and there is APK tool. It is very good. So by using APK tool, we can decompile or even we can build the application. So let's decompile the application by using the APK tool. So we have already this piva.apk file, APK tool. This is the command for use the decompile. You can see the APK tool. These are the commands in APK tool. So let's now now our application is decompiling, and as we can see, we got a new folder, right? And we can see the resources as we seen in this Android Studio project, right? So not all the resources we will find here, but similar to that resources, like resource value string, we can find a string here. Sometimes there are so many important information stored inside this string, right? And here we get the Android manifest file as we have seen in MOV-SF. So suppose we want to tamper something, right? Okay, let's tamper the manifest file. What we can do, we can camera, phone, record audio. We can remove this permission, or we can make the backup false. Okay, we have tampered the application. Now go back and again recompile it. Build, sorry, we have to give the same folder name. Now it is checking whether the source has changed. I don't know if they have any filter. They can verify it is the application is tampered or not. But you will get a new folder called destination and you will get a new tampered application, right? So this is the tampered application, right? Now we cannot install it until we have to sign it by using Java signer. We have the signer already, so I will go into my signer. This is done. This is also done. This is right. Resign. Now I am going to resign it. I was having a jar signer somewhere. I don't know. I forgot. I guess. Okay, let's see. Where is my jar signer? Sorry guys. Okay. Here and right. This is, we have jar signer here. So I can use it. I can copy this path and java hyphen jar just sign dot jar and I can give the APK. Now we will receive a signed one, right? I will change its name. Apps.apk. Right. Now we will try to install this, the Tamper one. So what I will do, I will uninstall the previous APK, this one. I uninstall it and uninstall complete, finish, no application, no. Now we will do ADB. We will install the tampered one. It is here, has been installed. Now you can see here, right? We have seen the password, right? In this this one here, test and very complicated password. Now let's try to log in with that password. Test, very complicated password. Now here we can see we logged in inside the application. We can find out the different links. Okay, it is opening web browser. These are the different practical actually here, right? So we have done with our this practical, and I guess we don't need this mobile Excel now in the future practical, right? Now we have seen the security issues like hard coded password already, because guys I was going into a very uh, in a flow, so I didn't care about the PPT. If I am going step by step or I am jumping, that's fine. Just the purpose of to execute the practical is to demonstrate the vulnerability. Now there is one more vulnerability called insecure data storage, and this vulnerability is still fine. So what happened in this vulnerability? We found some sensitive information inside the mobile device itself. Okay, let's try to get this vulnerability. Now for this we have to go to inside the shell, ADB shell. We are now inside the device. We can check the IP address. This is our IP address, and now we have to go to data. Now you see, we can see all the packages. So these are the folders as I described. It is managed by Linux kernel. It is like for Linux permission and sandboxing. So these are all different folders belong to different apps. So this is our folder here. We will go in this package and we will see, but right now these are the folders inside this file, right? Like shared folder, we can check if there is anything in this folder. No. We can check if this has something. Nothing, right? And sometimes there is a folder called files. It is not appearing right now because I guess we didn't execute anything, that's why it is not coming, right? If we execute, then it might appear. We can see app texture. This is a directory. We can try to get into a directory. And there is nothing in this. So okay, let's try to uninstall this tampered one and check. Let's try to uninstall this tampered one and see if it should not change anything. Okay, this is okay, now I tried to install this APK. This is not signed one, right? So that's why it is failed to collect certificate from this one. Nice. So we cannot install a unsigned application. So we have to go back. So we'll install this one. Now it will install it smoothly, right? Here you can find it, and and try to log in. Okay, this is the cross-site scripting vulnerability. So whenever whenever a application enable the JavaScript, if you found like the application has JavaScript enable and it is loading a remote URL, then you can do a then you can do a cross-site scripting. So you put your like this is here we have put our script and we put the URLs of that, and now we go, it will execute the cross-site scripting here. So this is how we find the cross-site scripting in mobile application. Right, now we go to our practical. ADB data form dot ht all the package data right still there is a folder, it's always appear here files, it is not coming, I don't know, no problem, but you will find some. So you can check this folder inside the package folder. You can check if they are storing any kind of sensitive data, or sometimes they also store inside the external SD card, inside the SD card. So you can also check in SD card as well, you will find it. This is root, and here SD card, and you can check. No, this is not down. Right now there is nothing, but you can check Android if something is there, data, and you can see here you can find here files. So this is credential.dat file. So sometimes they store some sensitive data inside the local device, and you can find test and password. So this is how sometimes you find token, API keys, JWT token, or sometimes encrypted token, sometimes MD5 hashes. So always try to check what they are storing inside the local device. This is for this practical. And now more SF I already explained. Other work we can find IDO attack, API vulnerability, access control issue, auth related issue, JWT token issue. So just for finding the IDO, API vulnerability, access control issue vulnerability, we have to intercept the traffic. We have to open the application, we have to intercept the traffic. So for doing this, we need to set up the proxy, right? Okay, now let's set up the burp proxy. And for doing the burp proxy, install certificate. We also need to install the certificate of our burp. Custom phone, if we have anything, nothing. I guess we already reset it. Previously I installed it, but yes, certificate is not there because the lock is not there. If we have to install the certificate, we have to also set up the screen lock. Okay, it will automatically tell us, it will force us to set up the screen lock when we will install certificate. So again, we have to install the certificate. Now what I will do is I will push the certificate. I will use the feature ADB push and push the certificate inside into the mobile device, right? So I will exit from here and I will go I already have the certificate. I will push ADB. This is the command. Push. You can see CACERT. These are the certificate you can easily push. But where we want to push, we can check here. ADB shall we go ADB. We are sorry, we are already inside the device, right? So we can put certificate here as well. If we want to put here in download, SD card download, we can put here as well. So just write this path, copy, and one file pushed. Now we go here, right? We are already inside the file because we are inside the device by using this command ADB shell. So now if we ls, we get the certificate, right? Now we can install the certificate. Just go into device, in settings, and when we search install certificates, we go to install certificate, we go to downloads. It is not here because we have to go here, and this is the certificate. We can name it burp. Now it will ask for screen lock, pin 1234 1234. Don't show notification at all. Now burp is installed, burp certificate is installed. Right, now time comes for applying proxy. Where is the Wi-Fi? This is the Wi-Fi. Go there, modify proxy, manual, and put the IP address here. IP address for what? For our primary OS, where we want the traffic to go through, right? So we can check the IP address here. IP config. Sorry, but this is the IP address of the device, right? This is the IP address of device, and this is the IP address of our OS. It will come. Where is the 0? This one, 0186, right? So we can put it. I already start the bug, so we can put it here, 192.168.0.186. Port we can give 8888. Now we have set up the proxy here. Now we have to start the bug for listener, the proxy. So what we can do, all interface edit. That's it. It will start intercept all the interface. Allow. Now just go to intercept. Intercept is on, off. Now let's try to open something. Let's try to open google.com. Now we can see the traffic is coming into a bub suit, and here we go. We installed the bub certificate. Now we can intercept the HTTPS traffic. Forward, we see the result. It will come. It will take time. So we can intercept off. See this result. It will come. Actually, this browser is not good. That's why. Now we open our application. This is our application. Check if we will go here. Click on go. This one. What happened? Okay. Okay. Fine. Two requests per day. Intercept is on. Will not come. Oh, now let's try this one. Let's try this one. It should come. What is the error? There's no need to worry about handshake because the application do not have any certificate, hassle clean certificate. Okay, let's set up again. No problem. Close this up. Let's signing open 7. Try to edit NAT. I will set up into this. Let's keep it NAT. No problem. And actually this IP is for bridge.is, yes, but fine because sometimes this create problem. Bridge and NAT. If it will not work, then we will set up the bridge one. What happened? Okay, it is opening. So this is the last practical actually. We have installed the bub certificate for intercepting the traffic. It got installed and it was working fine. Suddenly something happened, and we should also specify the address. This one. 8888 started. Okay, now we'll check. Traffic will come. Password 245. Okay. Traffic was coming before. It is not coming this time. Okay. Do one thing. Sorry guys, it is taking little bit time, but I want to show you because sometimes it creates problem, but it's fine. So now I will start intercept on this. I think we will get a different IP address as well. Our emulator will get a different IP address. It is okay, fine. It is starting. It is taking a little bit time. It should not take it. I don't know why it is taking a time. Okay. And sometimes like we need some Google Play stuff, so there is here open gaps, we can install it from here itself. You have to install open gaps on your virtual device. So when you install the open gaps, you will find Google Play Store and you will find the Google apps by default. Right now it is not opening. It is it's open now. 2, 3, 4. If we see KDB shall see the IP address 0183 and 57.102. Okay, and if we set up our VN0, yes, this is fine. Take it, fine. No internet, language. Interface, no problem. Sorry guys, sometimes it's happen. Connection reset. Okay. Nothing. I don't know what is happening here. I will just modify it on that and try to. This is the last practical actually. So after that, so basically we can find these vulnerability by using when we intercept the request and when we set up and intercept the request. When suppose idle we want to delete other user comments, so we try to change the comment ID, we try to change the user ID. If we want to delete some user profile data, and here like some API vulnerability like access control issue, authorization issue, and JWT token issues. And so this is the source code review. Here we can do because source code review is always good to find out the low hanging fruit of to find out the vulnerability before it's go to a production. So these are some benefit for source code review: detection, inflation, like we can detect easily, we can detect some hard coded password secret key is there before it goes to production, and we can detect some data storage definition as well, we can detect some weak algorithm uses as well. So these are the benefit for mobile application source code review. These are the some reference I took it, and that's all guys for this. Thank you very much for your patience and thank you for joining me today. Thank you guys.